Welcome back to Refreshing Careers. This is the second part of the topic time value of money. Before we start with today's topic, let us summarize with some important points of the previous topic, so that from the previous part, so that we don't get confused. Time value of money. Time value of money means the value of a unit of money at different intervals, at different points of time. That means the value of money today is not the same as the value of money it was yesterday, nor it is same as the value of money it is going to be in the future. That means if today I am with 100 rupees, let's say I am having 100 rupees. With my 100 rupees, I am able to buy 10 pens. After another 10 years, if I am having 100 rupees, like how I have today, with that 100 rupees, I will be able to buy just 5 pens. Why is this happening? 100 is the same thing. What is reduced? What is reduced is the value of money. 100 is not worth 100. The value of that 100 has depreciated. Okay, that's why this entire concept arises. This entire concept of time value of money is based on this point. Okay, and why it happens? Because money has got time preference, due to which it has different value at different intervals. Okay, and the next thing is this required rate of return. Required rate of return is the rate of return that any investor would charge for the money he has invested. For example, my friend wants to start a company. He has no one to help him with the funds. So I decide to give him 100 rupees. I have 100 rupees and I give him 100 rupees. And he says he'll return it after 10 years. So after 10 years, will I just accept 100 rupees? Because after 10 years, 100 rupees is not worth 100 rupees. Due to time value of money reducing, it will obviously be somewhere less than 100 rupees. So then what I do is I calculate the risk-free return. I calculate the risk-free return or the time preference rate. Let's say I consider time preference rate to be 8%. So I have given 100 rupees. Over that 8%, I consider it to be as a risk-free return. So I expect my friend to give me back 108 rupees. I am considering this only 108 rupees because he is my friend, and I feel that okay, 100 rupees I have given him 100 and he has to return me back an equivalent amount. So what I do is I feel that 100 today is equal to 108 rupees tomorrow, and that is why I tell my friend, you just give me 108 rupees, because here what is happening is 100 is equal to 108. 100 in the year 2022 is equal to 108 in the year 2032. So am I taking any extra money? No, I am not taking any extra money. I feel 100 is equal to 108. So I tell him you will give me 108, because these two amounts are going to be equal. 100 in the year 2022 will be equal to 108 in the year 2032. That's why I will tell him to give only 108 rupees. Okay, now let's say that I am giving it to someone else. Let's say I am in the business of funding people and earning money out of it. So I give some particular person, he wants to start a business, he comes to me and I give him 100 rupees. Will I just take 8%? Will I just give him at risk-free return, or will I just give him at this particular rate? No, I won't. I will charge extra rate. I will not just give it at 8%. I will put an extra maybe 3%. And this extra 3% is nothing but risk premium. This extra 3% is being put because I know that there's a lot of risk involved. What if that person runs away with the money? What if he never returns? So since there's so much of risk involved in this entire transaction, so I just don't charge this at this point, okay, now, because he's not my friend and I'm not in the mood to help him out. So I will not tell him 100 is equal to 108, so give me 108. I will say that you give me 108. I will tell him that you give me 108 rupees plus another 3 rupees. This extra 3 rupees, why am I taking? This extra 3 rupees is nothing but this is the risk premium. Extra 3 rupees is a risk premium. 108 is a value that's equal to 100, and this extra 3 is risk premium for the risk involved in a transaction. So as an investor, I would ask for this my required rate of return would be the time preference rate of the risk-free return plus the risk premium. That is, in this example, 111 rupees will be what I'll be charging. Okay, now this is a summary. Let's go to today's topic. Today's topic is compounding method and discounting method. We have seen what time value of money is. So, okay, there are two methods to calculate this time value of money. These two methods are compounding method and discounting method. Okay, let's see the definitions first. In the compounding technique, the future value of all the cash inflow and the cash outflow at the end of the considered period is calculated. Okay, and in the discounting technique, the present value of the future cash inflows and the cash outflow at time zero is calculated. These definitions this looks similar because it is similar, but there's these are very contrasting. Like in this, what we are doing is we are calculating the time value of money. That's the similarity. In both, we are calculating the time value of money. But what is different is we are calculating it at different points of time. In compounding technique, we are calculating at the end of the considered period. And in the discounting technique, we are calculating it at time zero. Time zero means at the base year or the year in which you have given the money. At the first year, at the beginning year, the start. That is called as time zero. So here in discounting technique, your calculations are at time zero, and in the compounding technique, your calculations are at the end of the considered period, and this is the difference. This is the main difference between these two. Okay, let's take an example. Now let's say in the year 2022, I have invested 100 rupees. I put it as minus because this is my cash outflow. Then in the year 23, I get back 20 rupees. This is my cash inflow. In the year 2024, I get back rupees 20 again. In the year 2025, I get back another 25 rupees. Then in the year 2026, I get back another 20 rupees. Okay, these are the transactions. The year 2022 to in the year 2026. So what is my time zero? This is called as the time zero. That's my base year. Okay, this is time zero, and this is the end. Then this is the end period. Okay. Now, see, I told you that the value of money is different in the different time periods. Okay, so now when we calculate something, it has to be equal, right? If I'm saying I want to calculate in the year 2022, so I have to make sure all these values, this 20, this 20, this 25, this 20, this entire thing has to be brought down to the values of 2022. It has to be equated, because money, see, in 2023, 20 rupees will not be worth 20 rupees. In 2022, it will be something more than 20. It might be 22, 25, as per the rate, as per the preference rate, it might be going to be little more than 20. Maybe some 1 rupee more, we can't say. So, but one thing we know is it is not 20 in the year 2022. It is something else, something more. Same thing goes for the year 2024. This 20 rupees will be something more than 20 in the year 2022. This 25 rupees will be something more in the year 2022. So, if I want to calculate in the year 2022, if I want to use a discounting technique, what I need to do is I have to bring down all these four values. I have to bring down all these four values to the year 2022. I have to equate it and bring it down to the values of 2022. For example, now let's say 20 is worth 25 in the year 2022. Okay, 20 is worth, let's say 20 is worth 24. 20 is worth 24, 25 is worth 21. Okay, 25 is worth 21 and 20 is worth some 18. Okay, so now calculation will become easy because now we can equate all these things. We can equate 100, 25, 24, 21, 18 because all these are as per the year 2022. As per the rate of the year 2022, the preference rate is 8%. As per that particular rate, as per that particular interest rate, everything has been calculated and brought down to that year. Okay, I'm just taking this as an example. It's not exact calculation for 8%. Just for explanation sake, I've taken this. So when I'm bringing on all these values to this particular time zero, this is called as discounting technique. This particular technique is called as discounting technique. Now if I do the reverse of this, it becomes the compounding technique. If I do reverse of it, it's the compounding technique. Like if I now want to bring everything to 2026, okay, I want to calculate all these things and I want to bring the value to 100 rupees. Will not be 100 in the year 2026. Something it will be lesser. So let's say it's going to be 50, this is going to be 18, this is going to be something like this. It's going to be lesser. So this value, this value, this value, this value and this value can be now equated. All these values can be equated. So we are bringing down all these values. So bringing down all these values to this particular time period, to this end time period, and then we are doing the calculation. This is called as compounding technique, where all the future values of the cash inflow. See, we are calculating future value of 100, 50, future value of 20, 10 and so on. When we are calculating the future values, are these the future values of all the cash inflows and the cash outflow and the cash inflows at the end of the time, considered in the considered period. It is called as compounding technique. When you are bringing down all the values to the calculating the future values of all the given values in different time periods and bringing it down to this end period value, end of the considered period value, then it is called as compounding. This is called as compounding technique. And what we previously did was called a discounting technique. In discounting technique, what we are doing, we are bringing down all the values to the value of 2022. We are bringing down all the values to the value of 2022. So the present, what we did was, we were finding the present values of all these values. We were finding the present values of all these values and then we were calculating. So basically we are bringing it down to time zero and we calculated. Time zero in this case is 2022. So in discounting technique, we calculated the present values of all these future cash inflows and cash outflows at the time zero, and then we found out the amount, the required amount or what we needed, we found out. This is called as discounting method. Okay, so discounting and compounding method are totally opposite to each other. And in the discounting method, future, we are going from future to present. In the discounting, all the future things are converted to present. That's the future amount are converted to present amount. In the compounding, what's happening is we are converting all the present amounts to future amounts. In compounding, we are calculating all the present amounts. We are converting all the present amounts to future amounts. That's the difference. I'll explain it again with examples and with formula so that we get a better idea of it. So the formula for calculating this is A is equal to P into 1 plus I to the power n. This is the formula for calculating the compounding, the time value of money is the compounding method. Okay. Here basically we can replace this formula with this future value is equal to present value into 1 plus I to the power n. Okay, both are fine. If you take it as this or that, anything is fine. Here, what is A? A is nothing but it is the amount. A is the amount at the end of the period. Okay, A is the amount. A is the amount at the end. A is the amount at the end. A is the amount at the end of the period. That was in the year 2026 as per our previous example. P is what? P is the principal. P is the principal amount. Okay, principal amount. P is the principal amount again at the end period. Okay, principal, that is in the previous example principal was 100, but since this is compounding method, we have to consider the this thing at the end of the period. We have to consider principal at the end of the period. Okay, then I will be the rate of interest. I is the rate of interest. N is the number of years. N is the number of years. Okay, so A is the amount at the end. A is the amount at the end of the period. P is the principal at the end of the period. I is the rate of interest. N is the number of years. This is the formula. Okay, now using this formula, let's solve some problems so that there's more clarity. Yeah. This particular thing can be, this particular method of compounding can be done through another way, which I'll be teaching in the next part of the video. Otherwise, this is going to be really lengthy. Okay, now let me take an example. Let's say there's a person. Okay, person A. He invests 1,000 rupees. Person A invests 1,000 rupees in a bank. Okay, he's invested 1,000 rupees in a bank, which offers him 5% interest compounded annually. Okay, so here they give him 5% interest compounded annually. Now let's find out, let's compound this particular thing and find out how much we are going to get as returns. Okay, so what is P? P is nothing but this is 1,000 is the P. I'll again repeat the question. There's a person A, he's investing, there's a person A, he's investing 1,000 rupees, okay, in a bank. He's investing 1,000 rupees in a bank which offers him 5% interest rate, and this is compounded annually. Okay, it's compounded annually. They have not mentioned N. Okay, N is not mentioned. So N I will be taking it as I'll be showing you for 1 year, 2 year, and for 3 year how it's going to be, so that there is more clarity. Okay, now let's take for year 1. Okay, year 1. Year 1, what's the principal amount? Principal amount is 1,000 rupees. Okay, 1,000 rupees. And interest rate is 5%. Now let's use this formula. We have to put this thing in the formula. So let's find the amount. Here N is equal to 1. We are assuming N is equal to 1. Okay, N is equal to 1. A is equal to 1,000 into A is equal to 1,000 into 1 plus I. I is 0.05 to the power 1. And when you solve this, you'll get 1050. So 1050 is the amount. 1050 is the amount that you'll get at the end of the period. This is how we calculate this. Now let's calculate the same for 2 years. Let's consider N to be 2 and see how it changes. Now here. Now let's consider N is equal to 2. Okay, we're taking N is 2. Your P here, okay, your P is same. P is nothing but 1,000. I is 5%. You have to put it in the formula. Amount is equal to 1,000 into 1 plus 0.05 to the power 2. When you solve this, you're going to get 1102.5. This is the amount that they are going to get at the end of 2 years. This is the calculation. That means at the end of 2 years, you will get an amount of 1102.5 if you invest 1000 rupees today at the rate of 5%. If you invest 1000 rupees at the rate of 5% today, the amount you will be getting after 2 years is 1102.5. 1102.5 rupees will be the amount that you will get. That's the same thing for 3. Okay. N is equal to 3. N is equal to 3. What's the amount? Again the same formula. Amount is equal to principal. Amount is equal to principal into 1 plus 0.05 to the power n. N is 3. And the amount will be equal to 1157.63. Okay, when you calculate this with calculator, you will get this amount. So you can check it, check the calculation once. 0.05 is nothing but this, 5 divided by 100. 5% is nothing but 5 divided by 100, which will be equal to 0.05. That's how we came to 0.05. Okay. Now let's go to the next technique. That is the discounting technique. Okay, now next discounting technique. This has got a similar formula. If you understood the previous formula, if you remember the previous formula, it's very easy to understand this formula because there's no much difference. Let me write it down. Okay, the previous formula what we studied was amount is equal to P into 1 plus I to the power n. This is the previous formula. Now in this, before, right, we are finding A. In this particular question, we are finding P. So the formula for this is nothing but P is equal to 1 plus I to the power n by A. So this becomes the formula. I have just shifted this particular thing below this. So it's nothing but P remains here. 1 plus I to the power n gets shifted below A. So it becomes 1 plus I to the power n divided by A. P is the present value. See, in discounting method, we could consider the present value. We are finding the present value at time 0. In the previous one, we are finding the future value. A is nothing but the future values, right? So in that particular method, we are finding the future values. That's why we took it in this way. In this particular method, we are taking it in this way because we are finding the present values of all the cash flows, cash inflows and the cash outflows. So I just shifted it. So if you remember this formula, if you remember this one formula, you can derive this formula through this. So it's not much difficult. It's basically one formula itself. Only thing what you're doing is this particular factor goes here. It becomes a denominator. It just shifts here. Okay, that's how we got this formula. So P is equal to this. Okay, now let me write it down clearly. And then again I'll explain you this with another example. So we have to remember just one formula in this. That makes things little easier. P is equal to A divided by 1 plus I to the power n. This is the formula. Now let's solve some problems. Okay, let me tell the question. There's a person A. There's a person A. He requires 1050 at the end of first year. There's one person who needs 1050 at the end of first year at the rate of interest of 5%. So how much should he invest today? So that after 1 year he gets an amount of 1050 rupees at the rate of interest of 5%. Let me put it down. So here what they said, A wants an amount of 1050. In future he wants 1050. He wants this amount after 1 year. The rate that is given is 5%. Rate given is 5%. So how much should he invest today is the question. So let's use the formula. It's very simple. Just substitute everything in the formula. 1050 whole divided by 1 plus I. That is 1 plus 0.05 to the power 1. And you get the answer as 1000 rupees. You get the answer as 1000 rupees. So this is the discounting method. This is the discounting method when you're calculating the present values. You can consider A as the future value, P as the present value, or you can even call it as amount, or you can call this as principal. It's your wish. P is nothing but present value or principal. A you can call it as amount, or you can call it as future value. Okay, in the next video we'll be studying future value, present value in a bit more detail. I'll be telling you what is this 1 plus I to the power n, how is this significant, and how this could be replaced by a table, and then the future calculation, the other calculations. The next video will be covering the present values and the future values. For today it's done. Thank you so much. Please do like and subscribe the video. Thank you.